everything in computers is represented by numbers. But what about words? How large language models represent words? How do they understand them? A very simple way would be to assign a number to each word in a language. So for example, a dog gets 1, a cat 2, and so on, as we go through all the items, the words, the objects in the language. But there are several issues with that. The first one is that we really don't know what these numbers mean. So for example, if I get 42, what does it represent? And what if I get two numbers, 42 and 47? Does it mean that these words, which are represented by these two numbers, are close to each other in terms of meaning? We don't know. We also don't know whether 1 is somehow better than 532. So to avoid ordinal relationships, a technique which is called one-hot encoding was used to represent categorical data. So how does it work with words? So let's say that our vocabulary has 3 words. Let's say that's a dog, a cat, and a rabbit. For each of these words, we create the matrix where the first column says the property, is it a dog? The second, is it a cat? And the third, is it a rabbit? And we fill the matrix, so where the row matches the property of the column, there is 1, otherwise it's 0. The advantage of this approach is that we avoided ordinal relationships, so it means that every 2 words in the vocabulary are equally distant to each other. So the distance between any 2 words is the same. But this is also a disadvantage, because in a language we want to have that some words are closer to each other. For example, a dog and a cat are definitely closer to each other than a dog and a chair. Therefore, a very clever idea was proposed in 2013. The approach is called word2vec, and this is a technique for obtaining vectors, vector representation of words which are dense, instead of sparse representations which contain zeros and ones. So the idea is that words which have similar meaning appear in text at very similar positions. So for instance, if we have a sentence, apples are really delicious, and we can really replace apples by any food, right? Because delicious is connected to food. And all of this is learned in very simple way. A very simple neural network is used for learning these vectors, which are called in natural language processing word embeddings. When we visualize these embeddings, we can see really interesting properties. For example, that these embeddings inherently learn the relationships, for example, between the countries and their capital cities. This discovery was a really great breakthrough in the field, and it was a great beginning of how we represent words in natural language processing. Later then, different architectures were proposed to improve these embeddings, and finally we end up in cases when models such as ChatGPT, they learn their own embeddings as they try to model the language. The best thing about word embeddings is that they are everywhere in NLP. They can be used regardless how they were trained. For example, they can be trained using some architecture and then used in another NLP application. For example, they are used in text classification tasks like spam detection and topic categorization. Or for example, for name entity recognition, which identifies and classifies entities like people, places, and organizations. So you can see this is a very interesting topic, and if you like the video and you would like to learn more, subscribe to this channel and see you in the next video.